Right, once again, we are back on air, and I want us to discuss the Gauteng Prelim paper of 2023. In particular, the first paper, because we are interested in exhausting this. So it is the Gauteng preliminary exam of 2023, paper one. Let's just run through this paper together and make the most of it. Right, the instructions are there, so I've just loaded the full paper here. And now we are beginning our time. It's about 10:30. It's 10:29. Must finish at 12:29. Looking at the first question, 1.1.1. What do we do here to deal with this one here? So the couple of ways to do this, the easiest way is to recognize this as the difference of two squares. Right, difference of two squares, which is exactly a squared minus b squared is a minus b into a plus b. So, right. We continue. So now, with that said, we solve more problems. How do we then solve more problems? Right, so now difference of two squares here, what does this mean? This means that from here we can be able to write this as, yes, how are you? Right, so we have this one, which is 2 squared equals 0. So the number 4 can be written as 2 squared, because 4 is 2 times 2. And therefore, this means that you have 2x plus 1 minus 2 into, okay, you put the minus, then a plus. X plus 1 plus 2, and this equals 0. And this is exactly the same as 2x minus 1 into 2x plus 3 equals 0, which means x is 1/2, or x is minus 3 over 2. So these become the solutions to this equation, but it's certainly one way to solve these problems. And there are many other ways to solve this problem here. So we continue. The next question is the one that requires us to use the quadratic. And we can quickly be able to solve that one. That quadratic, I'm going to just do it here quickly. Right, so the quadratic can be rewritten as 4x squared plus 12. We transpose the minus 12 to the other side, making it plus. Minus 11 equals 0. Solving this, we have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Minus b is going to be exactly minus 12. Because they said to correct two decimal places, it means we need to use the quadratic once they say this. Right, and then you have b squared, which is 12 squared minus 4a c all over 2a is 4. So we get exactly that. Now, what is then the solution to this problem here? If you use a calculator, you realize, therefore, that x is approximately minus 3,74, or x is approximately 0,74. Okay, so we have exactly this one here. Next, solve more problems and consider more questions to solve. More questions to solve. Right, now we get question 1.3. What do we do to solve this one here? So to solve 1.1.3, it's very, very obvious. How do we solve 1.1.3? Right here, obviously, we need to realize that we need to factorize these transpose terms, etc. So let's look at 1.1.3, the question. Right, so what that is that we can transpose we can move all the terms as follows. Right, so we have 9x squared. We transpose all the other terms. The 15 will therefore become negative 15x plus 4. We've transposed all the terms, and now the terms are on the side that is greater than 0, making it this greater than 0. Right. What is this? We're able to factor this out. What are the factors of these? The factors are clearly 3x minus 1 into 3x minus 4 is bigger than 0. Right, a couple of things to realize here. The things that are with the marks, they are critical values, and this has a minimum vertex. You look at the coefficient of the x squared, which is 9, a positive number, therefore it is a minimum vertex. You put the critical values here, you have, for instance, 1/3, and you have 4/3. So 1/3 is going to be here. Okay, so 1/3 here it is. 1/3, and this one is 4/3. Right, from which we realize we require that these be greater than 0. Greater than 0, we're looking at this part that is above here. This part that is above there. Greater than 0 would mean we can realize, therefore, that x is less than 1/3, or x is bigger than 4/3. Okay, so we have this solution. Next, we continue now. We look at 1.1.4. What is 1.1.4? 1.1.4 is about, and that can be solved. And we solve this here. Right, so we clean up the board now. Right, let's clean up the screen and remove all these now because it's making the board a little untidy. Now we continue to look at more of this. We look at 1.1.4. This one, how do we solve 1.1.4? Right, to solve 1.1.4, we proceed as follows. Right, so in 1.1.4, we look at the square root of 2x minus 2 minus the square root of 7 minus 2x, and this is 1. Transpose the one of the square roots to the right-hand side of the equation because you have 2 square roots. That is the technique we use to solve this kind of a question. If you transpose that, we have the square root of the 7 minus 2x plus 1. And then you have 2x minus 2. You square this, and you have 7 minus 2x plus 1. You square this, which is 2x minus 2 is equal to, if you square this one here, it becomes 7 minus 2x. If you square the square root, it goes away. Next, you have this one, which is 2 times this times that, which is 2 times the square root of 7 minus 2x plus 1. Right, further simplifying these things here, we get exactly 2x plus 2x, which is 4x. Right, and then we have this one, 7 plus that, minus 10, equals 2 into the square root, minus 2x. At this point, you can square both sides. You square the left, you square the right. Okay, this is perfectly grade 11 work. If you square like this, what do you get? You get exactly 4x squared, etc. Okay, you could further simplify this here. Okay, this here, you can take it to, you divide through by 2, making it 2x minus 5 is equal to the square root of 7 minus 2x. Okay, so you have that. So now you can just keep this one here. You can just keep this part here. And then at this point, you square both sides, which is 2x minus 5. You square this. You square this one. Right. Which means at this point, you have this, which is 4x squared. Minus 20x. You square the minus 5, it becomes plus 25, which is 7 minus 2x. And you have 4x squared minus 18x plus 18 equals 0. We squared both sides twice because there were 2 square roots. So we squared here and then we squared also there. So we divide through by 2, which is 2x squared minus 9x plus 9 equals 0. So which means that this is x minus 3. And this is 2x minus 3. Which means x is 3 or x is 3 over 2. Right, you need to substitute both equations here. If you put 3 here, it becomes 2 times 3, which is 6 minus 2, which is 4. The square root of 4 is 2. So you have a 2 there. You put 3 here, it becomes 7 minus 6, which is 1. So 2 minus 1 is 1. So this one passes, but you realize that this one doesn't work. So in other words, obviously this solution here is not a valid solution. Okay, it's not a valid solution. Right, so we move on to the next question. Next, we want to solve these equations here, which are simultaneous equations. How do we solve these simultaneous equations here? Probably there are a couple of ways to solve these simultaneous equations. And we proceed as follows to solve these simultaneous equations. Right. First things first, there are many ways you can solve this, but one way to look at this is to realize that this equation here can be written as this log equation is a plus 5, which is equal to 2 to the power 3. A plus 5 is now your exponentiate, becomes 2 to the power 3. 2 to the power 3 is 8. And that means a is equal to 8 minus 5, which is what? Which is 3. So 3 is one of the solutions to this. Once you get to one of the solutions to this, what you do is you substitute into this equation. So you take the 3, you substitute in the place of a, which means you have 3 squared b squared minus 2a is 3 times b minus 8 equals 0. which means this one is exactly 9. B squared minus 6b minus 8 equals 0. Right, and when you get to this point, we need to factorize this. What are the factors of this? The factors of this are, the factors of 9 are 3b and 3b. Those are the factors of 9b squared. And then now you have the factors of minus 8 are minus 4 and plus 2, and this result is 0. This implies that. It implies, therefore, that b is equal to 4 over 3, or b is equal to minus 2 over 3. Okay, so that's the answer. So next question. Right, so we've been able to solve for these particular simultaneous equations here as shown. We got a equals 3 and we got b equals 4/3 or b equals minus 2/3. The next thing is we put our effort together to actually solve problem 1.3. We solve problem 1.3. Right, let me get my screen cleaned up so that we can solve problem 1.3. Right, to solve problem 1.3, we certainly proceed as follows. Right, I'm just cleaning up the board a little. Right, so we're good. We're good. How do we do now problem 1.3? If p equals the square root of x plus 2 divided by the square root of 16 minus x squared, for which values of x will p be real? Right, so at this point, you'd have to, for these to be real, you need to realize that we must have that the x plus 2 must be greater or equal to 0. Because of what is under the square root, we take the square roots of non-negative terms, which means x is bigger or equal to -2. Also, we require that in the denominator, the 16 minus x squared cannot be 0, but it must be just positive because we do not take square roots of negative things. At this point, we need to solve this one. So to solve this one is like 4 squared minus x squared is greater than 0. Something we call the difference of two squares. The difference of two squares. Which means a squared minus b squared is a minus b into a plus b. Which means it is 4 minus x into 4 plus x is greater than 0. We are looking at this and it has a negative x squared, so the kind of associated graph, a parabola graph, is going to have a maximum vertex. You have critical values at -4 and +4. We're interested in where this is greater than 0, so we're going to look at the part of the parabola graph that is actually there. So as a consequence, you have therefore that at this point, what we have here is the following. You have -4 is less than x less than 4 because it means the values of x are actually between those. Giving us inequality 1, inequality 2. So, but for these to be real, we need to take both of these into account. So we need to draw a real number line. make allocations of the numbers. So we're going to put here the number -4, the number -2, the number 4. In which case, therefore, when x is bigger or equal to -2, you go to the right. When x is bigger than now, x lies between -4 and 4. So you have this. Our interest is actually in where these two overlap. So the answer is going to be there somewhere. The actual final solution to this problem would be that from -2 less or equal to x less than 4. Right, so we get this answer. So now we continue to solve the problems and you look at question 2, 2.1 and so on. Right, so we remove this. Anyway, we have solved this problem and this is the final answer. Next, we deal with the with question 2 and we solve all the questions. So to solve question 2, let's clean up the board. Right, so we continue right now to do question 2. Question 2 is about sequence and series. And sequences and series are extremely important because they are part of the grade 11 syllabus, but also part of the matric syllabus grade 12. Right, the following is an arithmetic sequence and that it is calculate the value of P. Okay, they have been told it's arithmetic, meaning there's a common difference. Right, and the common difference here is obtained as follows. So you have the second term minus the first term must be equals to the third term minus the second term. What is the second term? It's 2p minus 3 minus 1 minus p. Term 3 is p plus 5. Term 2, 2p minus 3. 2p minus 3 minus 1 plus p, which is minus 2p plus 3. Right, so we have this. Then what is the solution to this? What is the value of p? Right, so we have 2p plus p. Right. And this gives us 3p minus 4 is equal to p minus 2p becomes minus p plus the number 8. Meaning you have exactly 4p is equal to 12, which means p if divide 12 by 4, you get 3. So p equals 3. Right, so we've calculated the value of p. We have done question 2.1, and that is the answer to question 2.1. Right, in 2.1.2a, write down the value of the first term of the sequence. Right, so I'm going to write the answer on this side. The first term of the sequence, just substitute. So the first term is going to be 1 minus p, which is 1 minus 3. What is 1 minus 3? 1 minus 3 is minus 2. And that surely is the first term of the sequence. And you can even write it like this, that it is term number 1 of the sequence. The common difference? What is the common difference? Write down the common difference. We continue as follows. Right, so the common difference is going to be obtained by subtracting two terms that are consecutive. And therefore, we're going to write the following here. What is the first term? So the common difference, D, can be seen term 2 minus term 1. What is term 2? Term 2 is 2p minus 3. Term 1 we already know. What is term 1? It's minus 2. Okay, p we already know. P is 3. So we have exactly that there. Right, so yeah, we can do it like this, but yeah, we can do it slightly differently as well. We can just write out the sequence and be able to do that. So what we're gonna do, it's the same thing, but I feel it's gonna make more sense and it's gonna be a bit easier and more systematic in a way that will create the kind of pattern that you need for general um, reasoning. So we would have the sequence in the part B. If you put 3 here, it becomes 1 minus 3, which is minus 2. You put 3 here, 3 in the place of P, because P is 3, you have 6 minus 3, which is 3. You can even go on, you put 3 in the place of, so 3 plus 5 equals what? Equals 8. We want to get the common difference, so the common difference can be seen as the second term minus the first term. What is the second term? It is 3 minus the first term, so, and this is a 5. So now what is this? It is a 5. This is the common difference. It is 5. Right, you can also obtain the common difference by saying term 3 minus term 2, and you'll get the same answer. Explain why none of the numbers in this arithmetic sequence are perfect squares. Explain why none of the numbers in this arithmetic sequence are perfect squares. Okay, this is very, very interesting. Why are they not perfect squares? Right, so obviously you need to write this out. So in other words, we have the sequence. What is the sequence? You have the sequence. If you put 3 here, it's going to be exactly minus 2. It's going to be 3. It's going to be 8, and so on. Okay, if this is said, the question then becomes, why? Explain why none of the numbers in this arithmetic sequence are perfect squares. Okay, right. Right, let's look at this very carefully. Right, so obviously there are a couple of ways you can use to explain these here. Okay, let's look at the rest of the terms that are involved here. For example, what are the rest of the terms that are part of these? So you can extend these and say minus 3, minus 2, 3, 8. Right, and then you extend this sequence. What is the common difference? You've seen the common difference is 5. So it means that you're adding 5 to the preceding term to get the next one. And then you add 5 to 8, you get 13. You add 5, you get 18. You add 5, you get 23, and so on. Obviously, you can see that these are not perfect squares. So what is happening? With the exception of minus 2, what you have is that you have a term that is 3 or 8, which are not perfect squares. Right. So in other words, all the terms except T1 end in either 3 or 8. Okay, let me see what somebody is saying here. All right, that's fine. That's okay. I've seen Ayanda. That's okay. So we continue. We continue. Why is this the case? Okay. Once again, we can see that all the terms except T1, right, end in either we have a 3 or an 8, and then they end in a, this one ends in a 3, this one ends in an 8. Let's write that one down. All the terms with the exception all the terms except except T1, end in either 3 or 8, while perfect squares and in 1, 4, 9, 6, 5, 0. Okay, so you have a couple of perfect squares that have a tendency of ending in 1, 4, 9, 6, 5, and so on. So with that said, we then make that observation that obviously perfect squares like 100, like 25, like 36, and so on. So that is actually the reason. And that is the answer to question 2.1.3. And then now we'll continue to solve 2.1, 2.2.1, and 2.2.2, 2.2.3, and 2.2.4. And then move to question 3. Let's just move quickly enough. Right, so what I will do is I will clean the board up because we have solved up to 2.1.3, then we're moving to 2.2. Right, so we have the following. Right, the following sequence of numbers forms a quadratic sequence. So in other words, here we're dealing with a quadratic sequence. We're dealing with a quadratic sequence. So dealing with a quadratic sequence, we proceed as follows. We proceed as follows. The first difference of the above sequence also forms, the first differences of the above sequence also form a sequence. Determine an expression for the general term of the first differences. Right, the general term of the first differences. What are the first differences? Right, to get the first differences, you can just subtract here. Right, if you subtract, what is minus 2 minus that? A 1. This minus that. Minus 1. This minus that. Minus 3. This minus that. Minus 5. These are the first differences. First differences. Right. The formula is, they form, we have been told that they also form a sequence. This one, if you say this term minus that, you get minus 2, you get minus 2, you get minus 2. So there's a common difference, and this quadratic sequence will always have the sequence of the first differences forming an arithmetic progression. Right, which is an AP, an arithmetic progression. So A now is the following. What is A of this? The first term of this is going to be the number 1 of the first differences. We have n minus 1. The common difference is going to be minus 2. We have minus 2n. We have 2 plus 1, which is exactly 3. So yeah, that is what we get. So the first differences of the above sequence also forms a sequence. Determine expression for the general term of the first differences. Right, so right, if you look at 2.2, calculate the first difference between the 35th and, okay, most importantly here, we have determined the general term. Yes, please.
Isn't the first term negative 3?
Yeah, that's a good question. Isn't the first term negative 3? That's a good question. But here we're saying the first differences of the above sequence also forms a sequence. So we're looking at the first what? First differences. So the first differences are 1, -1, -3, -5. So we forget about that and we just look at the first differences only. So that the first term of that is the number plus 1. You agree?
Oh,
Okay.
yes,
Thank you so
sir.
much. Yeah, thank you so much for noting that. Okay, it's a very important point you're raising. In 2.2.2, calculate the first difference between the 35th and 36th terms of the quadratic sequence. Right, so what is the answer to this one? Calculate the first difference between 35th and 36th terms of the quadratic sequence. Okay, this is both grade 11 and matric work. So you must be able to spot the pattern here. But now between the 35th and 36th terms of the quadratic sequence, what is the first difference? Okay, so like between the first and the second, what is the first difference? The first difference is 1. Between the second and the third, what is the first difference? Is -1. So second and third is producing -1. Third and fourth, what is the first difference? -3. The question we are asking is the following. Okay, if you look at this one, the third, 1, 2, 3, the third and the fourth, the first difference is -3. It is term number what here? It's term number 1, number 2, number 3. So between the third and the fourth, you are getting term number 3 in the first differences. Between the first and the second, you are getting term number 1. Between the second and the third, you are getting the second term. So between the 35th and 36th, you are getting the 35th term in this. Okay, we start again because this is going to be then the matric exam and at grade 11, the grade 11 exam. Between the first and the second, you are getting the first term. So if they say to you, calculate the first difference between this term, 1, 2, 3, 4, between the fourth term and the fifth term, then the first difference is going to be term number what? 1, 2, 3, 4. But between the fourth and the fifth, it's term number 4. Between 35th and 36th, it's term number 35. Okay, we have the pattern. So we say the following. The formula, we have already learned it. Okay, I'm reading a news communication saying there's no load shedding until Tuesday or something. So I'm expecting that we can attend as much as we can. Meaning we can do our lessons even at 12 o'clock at night, midnight, to make sure that this mathematics sinks. Okay, the first difference now between 35th and 36th, if they say between 35 and 36, you consider 35 because of the pattern that I was explaining. Okay, I can even repeat myself. So what is -2 times 35? Is -70. -70 plus 3 is -67. And that is the answer. Right, 2.2.3. Determine an expression for the nth term of the quadratic sequence. An expression for the nth term of the quadratic sequence. Okay, so this one we can do the nth term of the quadratic sequence. And now this one is way too easy. Let's just Do it.
Sir.
Yes, any question? No question.
Yes, I'm still confused. When you were calculating the first, I do have a question.
Okay, yes, what's your question?
When you were calculating the first difference, why is it giving you 1, but when you use a calculator, it says -5?
Okay, thank you so much. Let's discuss that. What do you think, Mpo? You also have Mpo. Okay, look at these guys. Okay, let's look at these. You are subtracting to get the first difference, this number 1, right? Yes, is it 1 or is it 5 or is it -5? Let's check together.
It
So you
says
say
-5.
-2. You say this one minus that.
Yes.
Okay, so we say -2 minus this. So we say this minus that. So we say -2 minus that. So what is the answer? -2 plus 3. What is -2 plus 3? -2 plus 3 is the same as like if you are adding, these numbers, is this plus that. If you're adding two numbers that have opposite signs, like different signs, you take the sign of the bigger number. Which one is bigger between 2 and 3? It's the number 3. So you take the sign of the bigger number. And from the bigger number, you subtract a smaller number. So what is 3 minus 2? 1. So that's why I've written +1. Please use your calculator and say -2 minus into -3. And then surely the calculator will give 1. Can I use the calculator on the screen? Okay, let me bring a calculator. I have a calculator. Let me bring a calculator. Just a second. I want to see if this arithmetic is working well or not. Okay, here is my calculator. Right. With that said, if this is my calculator, let's calculate together. So I want to say -2 minus into -3. So to do that, you have to look at the calculator very carefully and use the correct operations. So now, where do we start? So you need this -2. Then you put minus, open bracket. So it's -2 minus into -3. So you put -3. Then you close. The calculator is giving me +1. And that is why I wrote +1 here. Any question? Okay, not only that, I can do the other numbers. Like I can say -3 minus that to see if it's -1. Let's check. Let's start with -3. -3 minus into -2. Then you close the bracket like this. So we have said -3, then minus into -2. We're getting -1, which is this -1 here. Next, let's check also if we say this minus that. It must be -3, so we start with -6. -6 minus this minus that. So it's -6 minus, but this 3 was subtracting is already negative. Then we get -3. Okay, so next we do that's the last one. We're just practicing. We have -11 Minus 11, then we have minus this. So it's minus 6 there. So you have minus 5. Okay, so this calculator confirms that indeed we are right. Okay, let's go full screen now and continue with the rest of the work we're doing. Okay, now I want us. Please come again.
Can I ask something?
Yes, please.
So, when we calculating the first difference between the 35, the 35, and the 36, are we choosing? So must you choose 35 or?
Yes, we need to
Because
choose
I think
35. We need to choose 35. Why do we choose 35? Because we used only T35. We did not use T36. Okay. The reason why we only, if they say between this and this, you only choose the one before, the first one. And you don't choose the second one. Yeah, it's because of the pattern. Let's start here. If you want to get this number 1 and they say between the first and the second, between the first and the second, would you use the first or the second? So or you actually are going to use both. Let's check. Let's think about this. If you're going to use the first, between the first and the second, the first difference is 1. But how can we prove that the first difference is 1 using the formula? Okay, between the first and the second, the first difference is 1. Right, and that difference is the first term. Between the first and the second, that difference is the first term. So when you say first and second, so here you have the first, you have the second, you have the third, okay, we are going on with our discussion, and obviously we were having a discussion with Ayanda, and Ayanda was looking at, before the technical glitch, was looking at why did we use T35 here? Because it's between T35, it's between the 35th and the 36th terms. But why did we use only T35? Okay, so that was sort of the question. And so, the answer is obvious. Let's discuss it together. Between T1 and T2, the number 1 is term number what? What do you think? It is term number 1. Between T3 and T2 and T3, the first difference between T2 and T3, the first difference is term number what in this first difference sequence? It's term number 2. Between T3 and T4, the first difference between T3 and T4, the first difference is minus 3. And if the first difference is minus 3, it is term number what? 1, 2, 3. This means between T3 and T4, we get term 3. Between term 2 and term 3, we get term 2. Between term 1 and term 2, we get term 1. So we always get the one before. Between term 1 and term 2, we get term 1. Between term 2 and term 3, we get term 2 of the first differences. Between term 3 and term 4, we get term 3, and so on. Okay, so I'm trying to respond to the question by Ayanda. So between term 35 and term 36, we get term 35. That is what is going to give us the first difference. Now, the expression for the determined expression for the nth term of the quadratic sequence, we find that one as follows. Let's just get it quickly. Right, I wanted to make space here for it. We start by writing -3 we write minus 2. We're copying the quadratic, this one. Then minus 3. Minus 6. Minus 11, and so on. Okay, let's get the first differences. What are the first differences here? We've already got them. We've got 1, minus 1, minus 3, minus 5. Then we get more differences. This one and this one is minus 2. This one and this one is minus 2. This one and this one is minus 2. Right. So we're answering question of the nth term. Okay, this one we always say T2a equals that one. Here we always say 3a plus b is equal to this. Here we always say a plus b plus c is equal to this. Okay, always we do this when dealing with the quadratic sequences. Okay. So now here, what is a? You divide here both sides. So this means 2a is minus 2. You divide both sides. Divide minus 2 by 2, you get minus 1. So a is minus 1. Then we get to the next one. 3a plus b is 1. So with 3a plus b is 1. A is minus 1. Plus b is 1, which means b is 4. Then we have a plus b plus c equals minus 3. Equals minus 3, which means c is equal to what? So we have 3 here, which is minus 6. What is the general term? The general term is always has a formula an squared plus bn plus c. Okay, I'm using my mobile network. I'm hoping that the quality of the sound is clear and I'm not breaking. Right, so a is minus 1, which is minus n squared. So the b is actually 4n and the c is minus 6. So this one here is the answer to the question about the general term of the quadratic pattern, and it is exactly that one there. Next question. The next question is about show that the sequence of numbers will never contain a positive term. Show that the sequence of numbers will never contain a positive term, because these are negative numbers: minus 3, minus 2, minus 3, minus 6, minus 11. Right, so the question is, can there be a positive term? So we analyze this. The general term already know. What is the general term? The general term in the answer, so now we're doing 2.4. Right, the general term is minus n squared plus 4n minus 6. The quadratic, the first derivative of the quadratic, minus 2n plus 4. Okay, we get this. Next, we equate this to 0. When you equate it to 0, you have minus 2n equals minus 4. You divide by negative 2 and you get 2. This means that you have T2 here. Right, so if you have T2, we want to get the, because this is a quadratic sort of function. It's a quadratic function, so it sort of resembles the quadratic graph with the maximum vertex, because the coefficient of the A is minus 1. If the A is minus 1, we have a maximum vertex, so T2 is that. Term 2. Okay, so we continue. What is the answer to this? This is 2 squared is minus 4. Minus 4 plus 8 is 4. 4 minus 6 is minus 2. So now we have T2 is minus 2. Then now, what does it mean? It means that the graph is like this. At n equals 2, the term is, so in other words, that means that the maximum term, okay, because this means you have the maximum turning points. If the graph is like this, it means you have the maximum turning point or the maximum stationary point. At the maximum stationary point, you can see therefore that the result is minus 2. The value of the maximum value of the sequence is minus 2, and it is at n equals 2 at position 2. It is term 2 that has the maximum value. Then the rest will go down and be less. So in other words, the maximum term is the minus 2 term is the biggest one, meaning the rest are smaller. With that said, maximum term is that, therefore, no positive terms. No positive terms. So yeah, we do not have any positive terms here. Okay, so try to think about this and make sense, because I'm going to give tests to you guys this week. We must go the extra mile. We need to learn more and more. If we don't learn during the day, we learn at night. If not at night, during the day, it's the last month. We can't falter. Hear my words. Let's look at question 3 about some series and sums. Okay, this means the sum to n terms. Determine T6. So if they've given you the sum, what is T6? Well, generally, to get T6, you proceed as follows. Right. Generally, to get T6, you must take the sum of the first 6 terms. You must take 6 terms and then subtract the sum of 5 terms. So to get term number 6, you add all 6. You take the sum of 6 terms, and then you subtract the 5 terms. Because if you have term 1, term 2, term 3, term 4, term 5, term 6. And then now you are adding all these terms, 6 of them. And then after adding 6 of the terms up to term 6, then you remove this. By subtracting, you remove this. Then you are left with term number 6. So they are just interested in term number 6. So to get term number 6 from the sum, you must take the sum of 6 terms and then remove the first 5 terms, and then you get term number 6. Okay, we are in business. So what is S6 here? You make n to be 6 in this formula. So if n is 6 in this formula, then you have 6 here like this. Then you have 5 like this. What is term number 6? Okay, if you add everything here, you get 145. If you add everything here, you get 101. 145 minus 101, you get 44. So they said determine term number 6, so just term number 6 is 44. How did you get term number 6? We want to get term number 6. To get term number 6 from the sum formula, you add 6 terms and then you subtract 5 terms. Okay. We continue. We continue. We continue. Right, for which values of x will the following series converge? So if you have 4x minus 3 in brackets plus 4x minus 3 all squared in parentheses plus 4x minus 3 cubed in parentheses plus and so on. For which values of x will the following series converge? Convergence, we're discussing series convergence. If we're discussing series convergence, we must first get the common ratio or the constant ratio. What is the constant ratio? Right, the constant ratio is obtained by saying term 2 divided by term 1. We continue. Term 2 divided by term 1. What is term 2? Is 4x minus 3. 4x minus 3, then term 1 is 4x minus 3. You divide everything, you get 4x minus 3. Right, so and therefore it means that at this point, what we have here is the constant ratio, which is 4x minus 3. Right, we want to find the values of x. And so the values of x would be such that there's convergence. We require that R be here. 4x minus 3. So you add 3. 3 minus 1 is 2. You add 3, you get 4. You divide by 4. If you divide by 4, you have 2 divided by 4. Divide by 4, you have 4 divided by 4. If you divide 2 by 4, is 1/2. 4 divided by 4 is 1. So the values of x for which the series converges are those x values that lie between 1/2 and 1. But obviously, we need to understand that at this point, what more do we have? We also have the restriction that here we are dividing these things to get the common ratio. And also, but we do not require that this be, for example, from this relation at this point. We will have a paradox at this point. I want us to analyze that. So would require therefore that the 4x minus 3 be not 0. Because it might be 0 for some values of x. We'll see which values of x. So we don't want these to become 0, always, when it comes to these sequences and series. In particular, this series. So if you solve for x here, you'd say that x, you transpose the 3, it becomes positive, you divide by 4. You see, the understanding, therefore, is that x cannot be 3/4. This is approximately 0.75. 0.75 is a number that is between 0.5 and this one is like 0.5. 0.75 is a number that's between 0.5 and 1. So we must say this is the case, but x is not 3/4, because if it's 3/4 and if it's 3/4 here and you put x equal to 3/4 here, it means therefore here you're gonna have 0, because if you put 3/4 here, 4 cancels, you have 3 minus 3, which is 0. And if you get 0, and this means that 0 is bigger than -1 and 0 is less than 1. Okay, as much as that is a true relation, but now the nature of the division we do suggests that we exclude this value there. right, suggests that we exclude this value there. The understanding being that we ordinarily desire that the constant ratio itself be not 0. Okay, just note that and follow the discussion. Let's look at 3.3. This summation. What is this sum? Okay, this sum means we're adding everything up. Let's add everything up. First, we start from 3. So wherever there is k, you put 3. So it's going to be -1. You put 3. Next, you put 4. Next, you put 5. Okay, you cube this now, which is -2/3. Now you put this one is -2/5. You divide by 30. 30 is the LCD. Perhaps a little bit more, we need to just simplify this because this is like 1/2. Right, 1/2. Otherwise, then you go to as far as 60. So I'm going to simplify this. Okay, I'm going to simplify this as follows. So then this is -2/3 -2/5. As we said, it is 30 in the top, then becomes -17. So this is the answer. So this is the answer. So in other words, the sum itself here, you can come and say the sum is -17 out of 30. You start from 3 to 5. From 3 to 5. Wherever there is k, you put 3. 3 here, 3 there. You put 3 there, 3 there. Next, after 3, you run from 3. The sum runs from 3 to 5. So next you put 4. You put 4, 4. Next you put 5, 5. And you get the answer. Okay, let's enjoy some of these basic things on graphs. Let's enjoy the graphs. These graphs are part of both matric and grade 11 syllabi. So yeah, if you look at the two graphs, the g of x graphs, write down the domain of g. What is the domain of g? Anyone? Anyone the domain? Well, to get the domain, you must just say x plus 3 cannot be 0. You know, you don't allow division by 0. And that means that you don't, x is not -3. That means x is not -3. Write down the range of h. Anyone? The range of h? Right, x is not -3, but x is an element of R. Here the range of age is going to be y is not 2. For the range, you say y is not 2, but y is an element of the reals, the real numbers. If the graph of G is shifted so that it coincides with the graph of H, how many units must the graph be shifted horizontally? Okay. How many units must the graph be shifted vertically? Next question. Okay, we need to answer these. Look, if the graph is shifted so that it coincides with, all right, that's an interesting question. Twice. Okay, let's think about it there. Paul is suggesting twice. Okay, that's an interesting one. So that they coincide. Okay, if they coincide, then obviously Paul is suggesting twice, which is okay. The question is, what number, because we are shifting, if the graph of G is shifted, this is the graph of G. What number do we add or minus, if you like? Do we add or minus from or to 3 to get minus 3? What number? What number can make, if you add or you subtract from minus 3, you obtain minus 3? What number can that be? Anyone? Okay, so in other words, we want x plus 3 to become x minus 3 so that they coincide, because it's horizontal. So horizontal affects only x, does not affect anything else. So we have x plus 3. We can see that if we subtract 6, it becomes x minus 3. So you're subtracting 6. And that means they're subtracting 6 now, because 3 minus 6 is minus 3. So that means 6 units. If you move the graph to the right, so in other words, how many units must the graph be shifted horizontally? Right, it must be shifted 6 units. But if we actually subtract, we either subtract or we add. If you add, it goes to the left. If you subtract, it goes to the right. So which means it's 6 units right. So yeah, 6 units right. So that x plus 3 becomes x minus 3. Okay, this is just part of the reasoning. It's not the answer. The answer is 6 units to the right. 6 units to the right, or 6 units right. How many units must the graph be shifted vertically? This week, I want us to embark on a war. A war. How many units must the graph be shifted vertically? So you need to look at this graph. So to do that, because you want them to coincide, the question is, what number do you add here to minus 3 over 2 to get 2? What number? There's a number you can add or you can subtract. If you have minus 3 over 2, you want it to become 2. What number do you add or do you subtract? So there are many ways to do that. So you can say, okay, it's minus 3 over 2. You are adding a number and you want to get 2. This number you're adding is the number of units you must shift to the graph. So this is 3 over 2 plus 2. What is 2 by 2? It's 4 plus 3, which is 7 over 2. 7 over 2 units, so it is 3.5 units. Okay. I said I changed the network because my Wi-Fi went off, so I'm just using my mobile network now. I'm running on Vodacom. Right, so I hope the sound quality is clear. So it is 3.5 units. Okay, so because now this negative number, you must make it positive. So you must add. So it is 3.5 units upwards. Upwards. Because you must add, you put a positive number there. Positive number moves the graph upwards. If you subtract from the graph goes down. If you add to the graph goes up. Okay, that is just the principle. Next question, or next point. Next point. Write down the equations of the asymptotes of G. Write down the equations of the asymptotes of G. What are the equations of the asymptotes of G? Okay, let's look at G. G is this one. It has two asymptotes, the vertical asymptote. To get the vertical asymptote, you take x plus 3 and you equate it to 0, which means x is minus 3. And then the horizontal asymptote is going to occur when y is minus 3 over 2. When y is minus 3 over 2. We have the horizontal asymptote and the vertical asymptote. Calculate the x-intercept of G. This is G. What is the x-intercept? The x-intercept of G is when what happens? To get the x-intercept, you let y be 0. Let y be equal to 0 in the graph of G. So you have 0 is 6 over x plus 3 minus 3 over 2. This is 3. Right, you solve for x, which means, okay, let's demarcate this because of this space. So you have 6 over x plus 3 equals 3 halves. Cross multiply, 2 by 6, 12. 3x plus 9. 3x. 3x is 3, which means x is 1. Which means x is 1. X is 1. Okay, let's see. Okay, sorry. Okay, thanks, Paul, for repeating that one. Right, we want to get, okay, Paul is saying I lost her. Right. I'm going to start from where I am at 4.5. Okay, calculate the x-intercept of G. X-intercept of G. How do we get the x-intercept of the graph G? G is this one here. How do we get the x-intercept? To get the x-intercept, you let y be equal to 0. When y is 0, wherever there is G, you put 0 equals 6 over x plus 3 minus 3 out of 2. So that is the x-intercept we're getting. We transpose the constant terms so that we have 6 out of x plus 3 equals 3 halves. This equals, you cross multiply to have 12 equals 3x plus 9. And therefore, this is 3x. We have 12 minus 9, which is plus 3. You divide both left and right by 3, 1 to solve for x. Dividing both left and right by 3, you get x equals 1.
So,
Yes, please.
where did you get the 12?
Which one? The
12.
Oh, the 12.
Yes,
Because
sir.
it's 6 times 2. We're cross multiplying. 6 times 2.
Oh,
Yes. Okay. Right. Yeah, 6 times 2 is 12. And then 3 into x plus 3. 3 times x plus 3 is like 3 times x, which is 3x. 3 times 3 is 9. Yes. Okay. And then we transpose the terms, which means 12 minus 9. What is 12 minus 9? 3 equals 3x. We can divide both left and right by the number 3. Dividing here by 3 by 3. 3 divided by 3 is 1. Okay, we need more power. We need to work extra hard. We need to double our effort. The exams are here. We cannot falter. Okay, this is recorded, so you'll watch the video again and again. Sketch the graph of G in your answer book and show clearly all asymptotes with the axis. Okay, I'm going to draw a small baby graph. I'm going to draw a small graph like here. So this is y and this is x. So x is minus 3. If x is minus 3, then you have your x-intercept. What is your x-intercept? It is 1, so it's going to cut at 1. But you also have y equals negative something, minus 1.5. So this one is y equals minus 3 over 2. Then your graph is going to have an x-intercept at 1. Right, so it's going to have an x-intercept at 1, but it's also going to have a y-intercept. It's going to cut like this. And then there's another part of the graph that is going to be, because this asymptote is going to go there, and this asymptote is going to go there. So another part of the graph is going to do this. So this is sort of the graph you're going to have. So this is the answer. Okay, so where to sketch the graph? This is just a rough sketch. Show clearly all asymptotes and intercepts with the axis. Okay, so obviously your intercept here is x equal to 1. And the y value is going to occur when you have this here. Right, so the intercept here, when you make x 0 to get the y-intercept in G, this is G. If you make x 0, you have 0 plus 3. 0 plus 3 is what? You want to get the y-intercept, so you make x 0. Whenever you show it's going to be 3 here when x is 0. And then you have 6 divided by 3 is 2. What is 2 minus 3 over 2? 3 over 2 is like 1.5. Okay? It's like 1.5. 2 minus 1.5, you get a half. So in other words, the y-intercept here is going to be like at 0.5. This one. It's going to be like at 0.5. Try to make sense of the graph. I can just draw a bigger one here. I can just draw a slightly bigger graph so that you can see very well. Right, so you have one that is cutting at y equals minus 3 over 2. X equals 1. Okay, so yeah, he's gonna cut it minus 3, excuse. Right, he's gonna cut it minus 3, just a sec. He's gonna cut here. We continue. I'm bringing my pen back. And I'm going full screen mode. Okay, it's gonna cut also at minus 3, so yeah. So this graph is gonna cut at 2 points. It's gonna cut it 1/2, and it's gonna cut it 1. And the graph continues. And the other piece of the graph is gonna be like this. So which means X is minus 3. Okay, I'm just drawing a bigger graph, okay? Right, for 4.6, so this is the answer to 4.6. Where they said sketch a graph and they show all intercepts with the axis and the asymptotes. Determine the value of K, determine the value of K if this one is an axis of symmetry. Okay, the axis of symmetry now will be passing through. The axis of symmetry passes through a point of intersection of the asymptote. So X for the asymptote is minus 3, Y is minus 3/2. Y is, okay, for the asymptotes, you just take the numbers. What numbers do you take? You just take the negative here, you take the Y as it is. You take the Y as it is here, and you take the negative X. Here, you make this equal to 0, so that X is minus 3, and you take the minus 3/2. So which means XY, which means this one is 3/2, which is X is minus 3 plus K. Right, so you have 3 here. If you move it across the equal sign, then it's negative by negative is plus 3. Moving it across the equal sign, which means K is minus 9/2. Okay, next. For which values of X will this be the case? Here, you are taking the function. There is a line. Now, this is a negative slope, minus X plus K. And Y is, K is minus 9/2, and X is negative as well. Okay, now this one is going to be a line of symmetry of negative gradient. The equation you've already got K equal to that minus 9/2, which means the equation is Y equals minus X minus 9/2. Right, so this examiner is trying to be creative here. The 6 over X plus 3 and minus 3/2, the 6 over X plus 3 minus 3/2, what is 6 over X plus 3 minus 3/2? It is G. It is G. So then it means you have G of X is bigger than minus X minus 9/2. We got the K to be minus 9/2. So we're looking for where the function G is above this line. Where is it above this line? This graph. Where is this graph above this line here? This is the line minus X minus 9/2. But there's a part where this graph is greater than the line. Where is it greater? Here you can see that this side, the graph of G is less. Here you can see that it is above here. But where does it start being above? And as you go on, it goes down. This line goes down by this. So it means that it is above from where to where? It is certainly above, just to the right of the asymptote, which means x is bigger than, right, x is bigger than -3. This is the answer to this. So x is bigger than -3. When you go to the right of -3, this graph of G is above and this straight line is below. So yeah, that is the answer. When x is bigger than -3, then you have that this graph is above, the straight line is below. Just note that part. The graph of G is reflected about the x-axis. So we are performing things we call reflections. It's reflected about the x-axis. Write down the new equation. So if you talk about the reflection about the x-axis, it transforms points xy. Is a transformation. It transforms points xy. Okay, a reflection about the x-axis, what does it do? If you reflect about the x-axis, you have a point whose coordinates are x and y, and you reflect. So the image is going to be somewhere here. You reflect about the x-axis. A point that is here, if you put a mirror, it's a mirror image. Its mirror image is going to be directly below on the other side. But same distance away from the x-axis, equidistant away from the x-axis. And therefore, if x is this, you have x, and then y is negative. Then y is negative, which means you have x and minus y, which means x and minus y. So in other words, if G is reflected in the x-axis, then you have xy, then you have x and minus y, so y is negative. So now they're saying write down the new equation. The new equation, if you speak about the reflection in the x-axis, means that the new equation is going to have same x, but y is going to be negative in the graph of G. What is the graph of G? We have seen that the graph of G is exactly this one. So G of x is this one. It is 6 over x plus 3 minus 3 over 2. Okay, when y is minus 3, y becomes negative. So here you'll put a negative for the reflection in the x-axis. Okay? That is already the answer. You just make y negative and then you are done. But normally you need to make y the subject. So you must write the answer in the form y equal to not minus y. So you must divide by -1. Dividing by -1, then the 6 is going to become negative. This one is going to become positive, because it was negative. Now we're dividing by -1 is positive now. So this equation is actually this one here. So the answer they want here is y equals minus 6 over x plus 3 over 2. So that becomes the answer to the question. And I believe that is clear enough. We move on to the next question. Okay, we have more graphs now. We're looking at question 5 that came in the Gauteng trials. We're gonna be doing paper 1, paper 2, paper 1, paper 2, because you're gonna write paper 1 first. So that this paper 1 is quite easy, but we must give it some treatment as well. We must give it attention. We must give the sequence and series attention. We must look at the graphs, because that is what is gonna make you pass. Okay, the graphs of F and G are sketched below. The graph of F and G, these graphs of F and G intersect at the points D and B. Okay, they intersect at points D and B. They intersect at points D and B. Here, D and B, they intersect. Points A and B are the x-intercepts of F. They are the x-intercepts. Okay, now if you look at these very carefully, there is a function F, which is minus that, plus 81 out of 4. Okay, so write down the coordinates of E, the turning point of F. Write down the coordinates of E, the turning point of F. It's obvious. What is the turning point? Because you have the graph of F, is minus into this minus 7 over 2 plus 81 over 4. So there's a formula. The formula says if you have y equals a into x minus p, normally we use p here, plus q, the turning point becomes pq. So if it's negative, then you have pq. You have pq. Write down the coordinates of E. 7 over 2, 81 over 4. So it means that here you just take this one. Because it's negative, you write it as it is. If it were positive, then you're going to put a negative. Then you have the 81 over 4. Those would be the coordinates of E, which is the turning point of what? Of the graph of F. Next question. Determine the average gradient between or of the curve of F between x equal to 1 and x equal to 5. X, 1, and 5. Okay, let's look at this one. What is the average gradient of the curve of F? Right, so I'm going to do it here. Okay, so the average gradient is going to be, so to find the average gradient, you must say x equals 1, x equals 5. Then you use this one. You must find f of 1, and then you must find f of 5. So if you make x equal to 1 here, use your calculator, what answer do you get? You will have minus, then you have 1 minus 7 over 2. You square these plus 81 over 4. Then use your calculator to get the answer. You put the 5, so you have 5 minus 7 over 2 squared plus 81 over 4. You get the answer. Right. So this one is 14. And this one is 18. The average gradient is y2 minus y1 divided by x2 minus x1. Is there at the back of the matric paper, this formula? Which means that you have y2 is like 18. Y1 is 14. X2 is 5. X1 is 1. 4 over 4 is 1. All right, so that is the average gradient. So the average gradient, we have seen that the average gradient is equal to 1. It is m equal to 1. All right. Next, calculate the value of A, the x coordinate of point D. What is A here? The x coordinate of point D for 3 marks. Right. Right, let's find the value of A. What's the answer? Okay, we continue to find the value of A. Look at that very carefully. That is 5.3. So it is a point of intersection of the two graphs. How to find the point of intersection of the two graphs in D? So to find this one, in 5.3, so you have F equals G, which is minus into X minus 7 over 2 squared plus 81 over 4. The graph of G minus 3x plus 24. Minus 3x plus 24. Okay, let's square. If you multiply everything here, which is minus x squared, 7x plus 8 plus 24. Which is plus 10x. Minus 10x plus 16 equals 0. So it's minus 2 minus 8. X equals 8, which means therefore x at the point D is either 2 or that. So we can see that it must be 2 because the other point of intersection is 8. But in other words, we have 2 here because the other point of intersection of the two graphs is going to be 8. If you order them, 2 comes first on the x-axis, and then as you progress on the x-axis towards the right, you have that x equals 8. Right, so point S is a point on the graph of F where x lies between 8, A and 8. Least ST. Okay, line, excuse me. Line ST is drawn parallel to the y-axis with point T on the graph of G. Determine ST in terms of x. Determine ST in terms of x. So we have ST. Okay, so to find ST, then you must subtract the two graphs. Which is minus x squared plus 7x plus 8 minus 3x plus 24. Which is minus that plus 8 plus 3x minus 24. ST. Minus x squared plus 10x minus 16. So now you need to determine ST in terms of x. So ST is exactly minus x squared plus 10x minus 16. The next thing is now you need to determine the maximum length of ST. How do we find the maximum length? To find the maximum length, we find the derivative of ST. So we find the dST dx, which is minus 2x plus 10 equals 0. And this means x is what? It's 10 out of 2. It's minus 10 if you move it across. 5. ST minus 16, and therefore the answer is 9. So which means the maximum they want, because the maximum length, here we are using calculus, this is the derivative. So the derivative means that if you have x squared, you bring down 2, and then it becomes 2. From 2 you subtract 1, and becomes x to the power 1, which is just x. The derivative of the x means that you have x to the power 1, you bring down 1, then you subtract 1 from 1, so that it's x to the power 0. X to the power 0 is 1. You solve for x. This is a derivative. How do you read this one? It is read dst dx, and you get this. So what is they want the maximum length of ST. The maximum length of ST equals that. It is 9 units. Maximum ST length is equal to 9. That is the answer. That is the answer. Next question. Let's look at this one now. They've brought some graphs in the Gauteng paper. We're looking at the Gauteng papers now. Right, and now we have a graph here that is of the exponential type, because it is f of x equals 3 to the power x. It is an increasing function because it is of the power 3. It's 3 to the power x. It is increasing. Sketch below. The point P has the coordinates minus 1 and 1/3 is a point on F. There it is. Write F inverse in the form y equals something. Write F inverse in the form y equals something. Where is F inverse? Right, so to write the inverse, learn this now. You get this in the exam. It's already there in the final paper. So f of x is 3 to the power x. Right, so what you say is that the graph of f is y equals 3 to the power x. Then the graph of the inverse is x equals 3 to the power y, which means that y is the log of x base 3. That's the answer. That's the answer. Next question. That's the question, so continue. We continue. Sketch the graphs of y equals f inverse and y equals f inverse of x minus 2 on the same set of x's in your answer book. Clearly indicate all intercepts at the x's. Let's sketch the graphs. But you must sketch a graph of the inverse. This is the inverse. You must sketch a graph. So we're going to do 6.2 at the bottom. Okay, so you need to know that the graph of the log is always like this. If the base is a whole number, so it is y equals the log of x base 3, so it's always like this. If the base is a whole number, if it's a fraction, it does that. If the base is a fraction. In other words, the log graph is going to be like this. If you have, for instance, y equals the log of x, if the base is like 1/3. Okay, so This is the graph of the log. The inverse, which is actually f inverse of x. Right, and then now you're going to translate it 2 units. If you subtract 2, it means that it is 2 units to the right. 2 units to the right. So always the graph cuts at 1. So if you move it 2 units to the right, it means that you're going to have 2 here, 3. 2 units is going to be 1 unit, 2 units. So it's going to be there. So here you're going to have the graph of f inverse of x minus 2. Okay. F inverse is the log. So which means here you're going to have the log of x minus 2 base 3. Okay, that like that. Because now in the wherever there is x, you put x minus 2. So even here where it is x, you put x minus 2. So that's the answer. Use your graphs drawn in 6.2 to solve for x if the log is less than 1. If the log of x minus 2 is less than 1. This is the log of x minus 2 base 3 is less than 1. The log of x minus 2 base 3 is less than 1. You need to use the graphs to solve for x, if that is the case. Okay, so obviously I would imagine that this question was drawn to scale, because now you need to compare the two graphs. This is the graph of the inverse. Now you need to compare with another graph, y equals 1. Y equals 1, so that you can consider the part where this graph is smaller than this inverse is smaller than 1. Smaller than 1, going down. Smaller than 1. So for what values of x will this be the case? It is to solve for x. Right. Anyway, because yeah, you need to look at that. So obviously, because here this one is not drawn to scale, you can't see that here, but you can be able to get the answer to 6.3. Right, so look. So which means x minus 2 is less than 3 to the power 1. Okay, you can move this one. 3 to the power 1, which means x is less than 3 plus 2 is 5. Okay, which means x is less than 5. But what is the restriction here? X must be bigger than 2. X must be bigger than what? 2, because the log requires positive numbers. So x must be bigger than 2. So x is bigger than 2, but x is less than 5. So we have this. I think that we need to take a break. We've been sitting here for just more than 2 hours. Obviously, we had a break. When we return again, we'll discuss what time. We'll do the rest of the paper. We'll finish the rest of this paper. All right. Yeah, so we're doing the Gauteng preparatory paper 2023 paper 1. Okay, so thanks a lot, guys. We'll discuss what time we return again. But for now, I'm gonna send you messages on the thing on WhatsApp for the afternoon. All right, so thank you guys. Then I'm gonna upload the videos in the next couple of minutes. Okay, so yeah, thank you guys. Goodbye. Goodbye, guys.
Bye, sir.
Bye, guys. Bye, Paul and Ayanda. Goodbye.